Hi, this question is about an ideal gas, and you see a container which contains an ideal gas. So these are the molecules according to kinetic molecular theory. The ideal gas have a large number of molecules which move in a random directions with different velocities. They hit with each other and they hit with the container walls as well. So they exert force on it. Okay, now, what is asked in this question? They say if we increase the average kinetic energy of the gas, right, of all the particles, of all the molecules, if it is doubled, then what will be the new volume? But remember the condition which is mentioned, that the pressure is constant. So first of all, we will find out the result by having an equation, an accurate result, but I will also tell you the conceptual side, that actually how the pressure was constant and the volume should increase or decrease. So stick with the video. So finding answer from equation is so easy, right? First I tell you what is the average kinetic energy. It is the sum of, it is an average of kinetic energy of all the molecules, right? And the kinetic energy of one molecule cannot be determined, but the average kinetic energy can be determined from the macroscopic property, which is temperature. So you know the average kinetic energy can be written as 3 by 2 Boltzmann constant times the absolute temperature, which is measured in Kelvin. Now, if they say the temperature is doubled, if it is doubled, it means that the temperature was also doubled. Okay, it simply means that it is also doubled because it is directly proportional to temperature. And by the way, why it was doubled? Because it means that we have given the heat to the gas. So this heat entered into the gas, it increased the kinetic energy of every particle, and hence the speed has increased. Okay, so when the speed has increased, these particles have exerted more force on the piston, of this container, and it is perceived, it is most probably that the gas should expand. Obviously the gas will not compress, okay, because now the gas possess higher internal energy. Okay, so well, I will come towards the conceptual approach later also. But if you apply equation, which is obviously, which equation should be applied, that is PV is equals to nRT, because that is for an ideal gas. So what factors are constant? So this is a gas of a fixed mass. So the volume can be written as nr over p if I write it in a one bracket, because all the things inside the bracket is constant times the temperature, right? So dear students, this is equation number one. You can say that this is the original volume. So after doubling the kinetic energy, I told you that the temperature will be doubled. So the pressure is still same. So this is a new volume is equals to n is a constant, r is a gas constant, and this is the T prime. So V prime is equals to n r over p into t prime, and you can put the value of t prime here, so which is 2t, okay, because we have double the temperature. So if we substitute the value here, so it will be equals to nr over p into 2t, right? So obviously what it is getting to, so it is, you can write it like this. So it is 2 times nRT over P, which is the original volume before doubling the kinetic energy. So V prime is equals to 2V. So that is the right answer of this question. Now let's talk about, on a conceptual side, it is good if you understand it as well. So the right answer should be C, which says it is 2V and not the other answers. Now, just quickly go through this idea that why the pressure was constant. So we know that the pressure is equals to the force over area, and here they are basically talking about the pressure of a gas, right? So why it remained constant? The reason is we know from the Newton's second law that the force is a rate of change of momentum. So delta P over delta T over area. Now here the area is, dear students, is the area of the piston, right? Which is not going to change. This area is obviously remain same before and after doubling the temperature. right? So it means that the only change that happened in a system is about the force, right? Something happened, the force remained constant. And why the force remained constant? Because force is a rate of change of momentum. So what we did, when we have delivered heat to the system, the molecules are now moving with the more velocities, right? So when they are moving with the more velocities, so this change of momentum will increase, because this is equals to negative 2 mu if a particle have a mass m, right, and the speed is u. So it is negative 2 mu over delta t. So what happened, when you have increased the temperature, the speed of the molecule increased, but at the same time, to keep the pressure constant, the gas expands, right? Why gas expands? Because this time factor should also have to increase. Only in that case the force can be constant. So I hope you understand the logic, that why the pressure is constant, because force is constant, and why the force is constant, because the momentum changed, and the time that took two particles to approach each other, they changed by the same amount, so that their ratio remained constant. Okay, so this is why the pressure is constant. So it means that the volume will increase. So that's why, and mathematically we have proved that this should be 2v.